Hi, let's continue and start this lesson. In the previous lesson, in lesson 7.1, we learned the negative powers and the zero power. So let me remind you, what did we learn in the previous lesson? In the previous lesson, if we had anything to power zero, you are going to say that's directly 1. So anything you raise it to power 0, you will say this is equals to 1. Also, if we had negative power, like for example, if we have negative x to the power negative 1, that's equals to 1 over x to the power 1. While if you have, for example, again, 2 to the power negative 2, so that's equals to, just to flip this 1 over 2 to the power 2, then simplify it, which is equals to 1 over, 2. So 2 to the power 2, it's a 4, and so on. And also, we discussed how to simplify some expressions. So that's what we did in the previous lesson. Let's start this lesson. So multiplying powers with the same base. What is the meaning of that? So they mean here with the same base if you have something like this. So 3 to the power 4 and 3 to the power 2, this 3 and this 3, we call them same base. So if we have them like this, we can directly add the power if we have the same base between the multiplication. Look at this. You know that 3 to the power 4, you are going to multiply it by itself 4 times. So 1, 2, 3, 4. So that's 4 times. Then times 3 times 3 2 times, which is this one. So if you notice that it's exactly the same and you are multiplying a number by itself 6 times, which is the sum for 4 and 2. So that's the idea. So here in general, we can say, if we have, for example, a, which is any number to the power m, times a to the power n, which is any number, but this a and this a are same, you can directly add the powers. So you can say m plus n, you can just add them and then get the result. Let me give you some examples. So here is more explanation. A to the power m, which is m times, you will factor it m times. Here again, multiplying by a to the power n, you will multiply it, this a by itself, n times. So finally the result will be a to the power this m times n times. Let me give you examples so you can understand the idea. So once I have this, I just would like to fix something. So let's continue our working. So here we have, if we have, for example, 12 to the power 4 times 12 to the power 3. What I need to do here, I need to write them what is each expression written using base only once. So since these are same base, I'm going to add the powers. So directly that is 12 to the power 4 plus 3, it's 7. Keep in your mind, if you have, for example, 12 to the power, for example, 4 plus 12 to the power 3, that's not equal to 12 to the power 7. Keep this in your mind. It's wrong. If you don't have multiplication here, you cannot add the power. While if you have multiplication, you can add the power. Let's continue this one. So negative 5 and negative 5, they are same base. So I'm going to add the powers. So negative 5, all this to the power 7, negative 2, negative 2 plus 7, which is equals to negative 2 plus 7, which is 5. That's all the story. So this is really easier than the previous chapter. Let's continue. Just I want you to notice one more thing. If you have, for example, 12 to the power 4, and you have, for example, 3 to the power 2, you cannot, here, you cannot add the powers. You cannot write anything. You cannot add the powers. Please be careful on that. I'll give you more details about this in the coming lessons. So let's solve this one. 8 and 8, they are same powers. So we can say same base, we will add the powers. So 3 plus 6, 9. Now, look at this one. So 0, same base, we will add the powers. So once I add the powers, plus 3, minus 3, plus minus 8. So that will be here, that will be minus 11. So all this to the power negative 11. We learned in the previous lesson how to write this. This is will equals to 1 over negative powers. You will move it down. 0.5 all this to power 11, to the power 11, positive 11, because you moved it down, so that's what you need, so it will be to the power 11. Look at this, 9 times 9 times 9, they all the same base, just add their powers. So 9 to the power negative 3 minus 2, negative 1, so from this one to this one, this will be negative 1. Negative 1 plus 6 will equals to 5. So that's 9 to the power 5. Let me give you more exercises. So here we have again same idea, 7 to the power 3, 7 to the power 4. So that is 7 to the power, same base, add the powers, exactly the same our objective. We are going to multiply powers that have with the same base. So this is the base. As you know, you learned before the powers and the exponent, which is if you have 2 to the power 4, that is your base. That is your powers, just to remind you. So same base, add the powers. So 3 plus 7, it's also 7. Very nice. Let's move to this one. Same base, all of them same base. 2 plus 7, that is 1, directly 1. If we added 0, no problem. So 2 to the power, the result won't change. If I say 2 plus 7, which is 9, 9 plus 0, it's 9. So same thing. So that is a 9. This one, again, all of them same base. I'm going to add the powers. 12 plus 5, it's what? It's 17. 17 plus 2, it's 19. So negative 6 to the power 19. Now I have this one. exactly same idea. 5 to the power, all of them same base. So add the powers. -2, let me add them for you here. -2 plus minus 4. That's what I have from the here. But the rule tell me it's addition plus 8. So that will be -6 plus 8. Don't forget your sign rule. So the sign rule tells you these are different sign, subtract them, then take the larger. So it's 2. So 5, finally, it's 5 to the power 2. So that's 5 to the power 2. Now, this one, exactly same idea. So once you try this girls, please make sure that you try them and practice them alone, then check my answer. Exactly same thing that I do with you in the class. Try them alone by yourself and turn on the video, then just continue the video to see. So 5 minus 5, which is 0. Anything to the power 0, according to what you learned in the first lesson, is directly 1. Here is the last one. 9 to the power, all of them same base. Add the powers. Between them multiplication. Keep your mind, because I will give you something different in the coming days. We have between these bases, between them multiplication. If I don't have multiplication, I will do something else, something different. So 6 minus 4, it's 2. So that's between them 6 minus 4, 2. 2 minus -2, it's 0. So again, will be 1. So this is 9 to the power 0, so it will be 1. So we finished the basic thing. So the basic idea here, if we have the same base, multiplying powers with the same base, if I have same base between the multiplication, I'm going to add the powers. Let's see if we have algebraic expressions. Look at this. We need to simplify it. Focus step by step. Step 1. If you have numbers, multiply them. If between the multiplication, you don't need to confuse and say, Miss, these are not like terms. No, we don't have addition. We have multiplication. So step 1, multiply the numbers that you have. So 4 times 9, 36. I multiplied the same number. Then the remaining thing, I will write them. Z to the power 5 times, these are the remaining thing, Z to the power -12. Cool. I have the same base. Even if they are letters Z and Z, same base. So I'm going to add their powers. So 36, drop 36 as it is, then Z to the power 5 plus -12, 5 plus -12, which is equals to -7, right? According to the sign rule that you learned before. So that is -7. I should continue my work. I learned if I have negative power, I can move it down. So I will keep 36 up because it has positive power. It's already ready. Nothing to simplify it with. Over Z to the power 7. I moved it down to make it positive. So step by step. Again, step 1, look at the numbers. Do you have powers for these numbers? No. I can directly multiply 2 times 9 times 3. So let's multiply them together. So we have 2 times 19, 2 times 9, it's 18, 18 times 3, that will be 24. So that will be 3 times, it will be 5. So finally, I will write here that's equals to 5, 4, 54, then I will take the rest of things that I have. Now it will be A. If there is nothing, which means A to the power 1, which means this A times B to the power 4, A to the power times, I'll put this dot, times to the power 2. What do you notice now? You notice that I have the same base, this one and this one. But this one, no, nothing with this one. Be careful. So since I have these exactly the same base, so I'm going to add their powers. So let me continue. So that is 54 A to the power. If there is nothing, that means it's a 1. If there is nothing again, that means it's a 1. So 1 plus 2, it's a 3. Times, drop this one, just drop it. B to the power 4. You are done. All the powers positive. The multiplication done. There is nothing to simplify it with. Let me give you more exercises related to that. Again, once you watch my video, try to understand the problem, then try to practice the exercises. Here we have this one. The first one, 5. Exactly same idea. 5. The coefficient here, nothing, which means 1. 5 times 1, 5 times 3, it's 15. Then I have x and x, they all the same base. X, x, x. Between the multiplication, I have the same base. I'm going to add the power. So 4 plus 9, it's what? 4 plus 9, it's 13. 13 plus 1, it's 14. So x to the power 14. I will continue with this one. Negative 4, 7, 2. So 4 times 7, it's what? It's a 28. 28 times 2, 28. Let me do it step by step for you. 28 times 2, which is equals to, here 16. You have then 4, 5. So 56. So 56, the multiplication, don't forget the negative, negative 56. Then the remaining things, c to the power 3, d times d to the power 2, c to the power negative 2. I notice that c and c, same base. So I'm going to add between them multiplication. So I'm fine, nothing else. So I can add their powers. So negative 56 c with this one, with this c, 3 minus 2 or 3 plus minus 2, it will be c to the power 1. If you write it or not, you don't need, drop your d. So d to the power 2. I'm done with this one. The last one, 1, here the coefficient nothing, which means 1, times 1 times 12. So it's a 12. 1 times 1 times 12, it's a 12. Then j with j, they are same base. I'm going to add their powers. So their powers will be 2 plus nothing, which means 1. If there is nothing here, as I said, it's 1. The power is 1. So j to the power, be careful with this one, to the power 3. I will drop my k times k to the power negative 2. Oh, you learned yesterday that negative 2 should be moved down. So 12 j 3, I will move it down. I'll put fraction k to the power 2. I will give you more exercises, but please make sure that you try them by your hand. Now reasoning. explain how to multiply the expression x to the power a times x to the power b times x to the power c. Exactly same idea. Since you have same base, you are going to add the powers. But since these are not numbers, you don't need to worry about them. So just say it's x, a plus b plus c. So a plus b plus c. That's what we are doing in our mind here. We just calculate them directly. But here, since I have the same base, I'm going to add the powers. Exactly the same idea. Let's continue. Let me give you more exercises to make sure that you are confident from this one. Again, once you watch my video, try to solve them alone. Then check your answer from my video. Then let's look at this one. Same base, add the powers. Between them again, between the multiplication. If between them other than multiplication, I should focus what to do. If I have addition or subtraction, I cannot do anything until now. If you have division, you will see it in the coming lessons. So 3 and 4, it's 7. 3 plus 4, 7. Again, you are adding the powers. If you have the same base between the multiplication, please don't forget that. If you have parentheses like this, that means multiplication. You don't need to worry about them. X with the X, same base. Y with the Y, same base. Let's do that. So X with the X, which will be X to the power 5 minus 6, it's minus 1, isn't it? It's minus 1. X and X. We are going to add their powers. 5 minus 6, which is equals to minus 1. Now I will see what should I do with y. Y to the power 2 and y, which is y here to the power. Here is nothing. That means it's look 1. If there is nothing again, it's 1. I repeated it for you this many times so you can keep this in your mind. So 2 and 1, it's to the power 3. I'm done with this one. I just need to do one more step. Since I have negative power here, I must move this down, but I will keep this y to the power 3. I will keep it up. So y to the power 3 over x. I should not say 1. If you want to write x to the power 1, no problem. If you don't want to write it, no problem, which is exactly same. The power 1, the positive power 1, no need to write it, no problem with that. Let's continue working. Step 1, multiply all the numbers that I have. 5 times 1, it's 5. C and C, same base between the multiplication, add the powers. So 4 plus 6, it's C to the power 10. Look at this one. Step 1 again. 5 times the 3, it's 15. 15 times the 3, it's 45. So that is 45. Now I will focus on the numbers that I have. X with X. So these are same base. I'm going to add the powers. So 5 plus 2, it's 7. Let me change the color for you. What is the remaining here? The remaining only this y. We used everything, only y. Why nothing to simplify with it? So I will drop it as it is. So 6 to the power, y to the power 6. Keep in your mind again. I did the numbers together. I multiplied them. Then I look at my expression. I saw this x and this x, same base. I added their powers. Let me solve with you this one. Step 1. I will look at the numbers. Between them again, multiplication. 4 times 2. It's 8. Then I will look at the t that I have. They have the same base. I'm going to add the power. So t to the power, when I add negative 5 minus 3, which is negative, I don't repeat for you. I'm confident you understand the idea. I know the power down. So 8 to the power to make it positive power. T to the power 8. The last one, if that we have numbers. Negative 1, negative 4, 12, 5. So we are going to multiply all these numbers. So it will be negative 1, 4 times 12, it will be 48. 48 times 5, 48 times 5, so that will be 40, 4 to 20, 20 and 4, 24. So 240. You have your calculator. I'm sure you won't calculate like this, but I would like to share the basic calculation, which is very important. You need it. So we have now, let me look at my expression. I have this m with this m. The same base, m, same base. Between them all multiplication, no problem. So 2 with 1, so it will be m to the power 2 plus 1, 3. Next, if I have this r with this r, same base, I'm going to add their powers. So r times r to the power 3 minus 2 will be minus 1. I learned in the previous lesson what should I do with negative power. So I'm going to say negative 240 m to the power 3 over r to the power 1. So that's what we need. We are done like that. If you want to write this one or not, it's up to you. So that's the solution for all these exercises. Now here, before I start explaining problem 3, I would like to review with you some basic information. Because this basic information, it should be given in the previous book, which is scientific notation. You did not know what is the meaning of scientific notation, but first of all, scientific notation, which is the number that you might talk it. I don't know if you talk it in science or not. I don't know. Anyway, let me review this with you. So scientific notation, which is the numbers look like this. So to the power, for example, 3. So you have the first number. It should be between 1 and between 1 less than 1, more than, from 1 and less than 10 times the second number 10 to a power. This power could be positive and could be negative. So keep in your mind why this is useful, and we call it scientific notation. This is useful for the big numbers and for the small numbers. Let me give you an example. For example, we have, let's say, 3, for example, sometime very difficult to read 300 million, for example. I would like to write for you, for example, 300 million, okay? So this is very big and very difficult to write. If I want to write this in scientific notation, I can say, just this is 3. You know, if you have this, the decimal is here, right? So you can say 3 times 10 to the power 1. Count the zeros. You will move this decimal how much? 1, 2, 3, 4, 5, 6, 7, 8. So, since you have 8 zeros and you will put the decimal here, which is here, the decimal 3, so to the power 8, positive 8. While the opposite, if you are going like this, you are moving your decimal like this, you will plus the power, you will put them positive power. Let me give you another example. For example, if you have very small number, like for example, like this, that's enough. So this is my decimal. Can you see that? This is very small number. I want to write this in scientific notation. So that will be 1, 2, 3, 4, 5. So I need to put my decimal here at least so I can have acceptable number. So that will be, or let's move it one more to make it whole number. So 1, 2, 3, 4, 5, 6. So I'm going to write 4 times 10 to the power negative 6. But just I want you to know that this is not my main concept from this lesson. But my lesson depends on this concept, and I want you to know that because I don't know your knowledge in this part. That's why I started to review this with you. So once you move your decimal to the right in scientific notation, you will multiply your powers with a negative. You will minus from your power here. Once you move your decimal to the left, the opposite, you will put this one positive. So that's just basic idea. What do we have to do here? They gave you here example and you will see my PowerPoint. So look, 1, 2, 3. So you moved it to 3, so they put this decimal here and they put here times 10 to the power 3. But what is my main concept from this lesson? What do I need? They gave you here word problem immediately, but I will give you basics thing before I move to my word problem. Let me give you this easy example. My main goal here in problem 3, if you see it, multiply scientific notation. If I want to multiply scientific notation, again, I will use the same idea that I did with you in the previous part. 5 times 9, it's equals to what? 5 times 9, it's 45. Isn't it? Then you will take 10 to the power 6 and 3 to the power 6, to the power 3. They are same base, just add their powers. So that is 10 to the power 6 plus 3. So 6 plus 3, so that's 9. So that's what I need from this part. That's the basic concept. But they said here, write the product in scientific notation. So keep in your mind, scientific notation, this number should be from 1 and less than 10. From 1 and less than 10. But I have here 45. I need to move my decimal. That's why I explained for you the first part. You know 45 whole number. And you know the whole number, the decimal for the whole number here. This one exactly the same as if I say this, right? Exactly the same. Here is many zero. This is exactly same. So I need to make this number less than 10. So I need to move my decimal 1 unit to the right. To do that, I need to make some change with my power here. So that will be 4.5 times, I moved my decimal only 1 unit, right? Since I moved it 1 unit, I will add 1 to my power. So I will add plus 1 here. It will be to the power 10. I will give you more exercises related to that. Let's move. So you have here these. Again, multiply. These we call them, as I said, scientific notation. Let's multiply them. 2 times 4 It's what? It's 8. Same base, add the powers, times 10 to the power 6 plus 3, it's 9. My question is, now they said that in scientific notation, if I don't say that, you don't need to worry. So scientific notation, is this in scientific notation? Yes, this number is less than 10. So I'm fine with that. 8 times 10 to the power 9. That's okay. Again, next, 2 times 3, 3 times 2, 6 times 10 to the power 5 plus 8, which will be 13. Is this in scientific notation form? Yes, it is in scientific notation form. So that is because this 6 is less than 10. I'm fine with that. And greater than 1. If I have something like this, I'm not worrying about it. That's exactly the same as if I say a to the power 2 times, for example, 2 to the power or 2. So I'm multiplying these two numbers and leave this with the one including power. So that is, it will be 12 times 8, just to multiply them. So that is 16. So that is will be 96. So that is 96 times 10 to the power 20. I hope you understand the scientific notation so I can start my problem 3. Now let's go back to our book. In your book, they wrote for you directly word problem. And this word problem actually, it depends on playing with units. As you know, if you need, for example, again, this is related to something from before, from previous lessons, but let me give you a very simple example. If I have, for example, I need to find meter. I have 2 different units, let me say. So these 2 different units, let's say, for example, 3, or let's say hours per, for example, meter per, for example, hour. So I can remove this and I have just this one. If I, for example, multiply the time, and here I'm multiplying a quantity which is represent speed, like we said, always we said once we drive, meter per hour or kilometer per hour. So that's why I wrote this, which is represent speed, and this is represent time, this is represent distance. I need meter. So to figure out this, I wrote my 2 quantities so I can cancel this one with this one, between the multiplication, and the remaining is m over 1, which is, that's what I need. That's exactly the same idea here. So that's what we are going to do. Let's read, what do we need? Here, if you notice that we need about how many molecules of water does the droplet of water shown below contain. So I need the molecules. Instead of m here, I need the molecules. Let me write the molecules for you. That's what I need. I'm sorry because I'm writing again by mouse, so it is very difficult to write by mouse. So that's what I need. I need to find the molecules. Again, I'm going to analyze the units that I have in the problem so I can get exactly the same idea here and cancel some of them with the others. So the first one, they gave me here 1 cubic meter. Okay, 1 cubic meter of water. It has a mass about 9, this number, 9.98 times 10 to the power 5 gram. How can I write this? How can I write this? 1 in 1 gram in this one, 9.98 times 10 to the power 5 gram, that's per 1 cubic meter. So that's a unit rate. So which means that's equals to, I'm going to write this quantity that I have. So this quantity that I have, it's gram, I will write G only, gram over cubic meter, I will write M cube. Okay, that's how I represent the unit for this number. So again, the unit for this number, our 1 cubic meter of water has a mass. So this mass of about 9.98 times 10 to the power 5 gram. So I have this number gram, let's say gram for 3. I will make for you easy number. Gram per, for example, meter cube. Cubic meter, which means a cubic meter. Now, next, each gram of water, look, each gram, now this is one, each gram of water contains about 3.34 times 10 to the power 22 molecules of water. So that is molecules of water in each gram. So that means I can write this quantity or this unit by writing molecules of water. I'll write this molecules just MO easier over gram. The remaining number that I have, which is this number, which is the quantity for this number, meter cube. Now I can use exactly the same way as I did here. So I'm going to simplify this one. So that will be m to the power 3, m to the power 3, and I can cancel this out and this out. So the remaining is molecules of water, and that's what I need. Now, great. I can substitute these numbers related to these quantities, right? So, or these ratios. So this will 10 to the power -7. So that's the first one. Now the second ratio represents this number. So that's 9.98, sorry, times 10 to the power 5. Then finally, the last number, which is this one, is represented 3.34 times 10 to the power 22. So the basic concept here is this part. How to multiply scientific notation, as you see here. So that is equals to just multiply this number with this number with this number. Just multiply them all by your calculator. So once you multiply them all by your calculator, you will get 1.13 times 9.98 times 3.34. So that will give you big and long number 37.66, and many numbers around them. You don't need to write them all. Times what? Now I will look at the 10th. Let me just change the color for you. So that is here this 10 with this 10 with this 10. They all same base. Between them all multiplication. Just add the powers. So let's add the powers. So that is 10 to the power negative 7 and 5. It will be negative 2, negative 2, and 22. It will be 20. Now here in this question, they did not say write this in scientific notation. This is not scientific notation because this number is greater than 10. You must make it less than 10 and greater than 1. So how can you do that? You need to move this decimal here. So to do that, just move. Let's estimate it first. We can make it easier than this one. So that is 37.7. Am I right? So times, that's how we estimate before we do anything. 22. Okay, scientific notation. What is the definition of scientific notation? The first number should be between less than 10 and from 1 and more than 1. 1 and more. So that's equals to, I need to move my decimal here. So I'm moving this one to the left. That means add to the power. It's the opposite. So 3.77 times. What should I do with this power? I should add one more. So that will be to the power 23. So that's the idea from this problem. So keep in your mind, maybe you face difficulty with analyzing the units. Why must you are multiplying all the given numbers here? Because I need to find the multiples. The multiples, this is the analysis of the units, the given units in the problem. It is like that. How I got this? So meter cube, it's from this one. That's what they gave me here, meter cube. But you might just need to focus on this one. Why I wrote this as a gram? It's already given. They are telling you 1 cubic meter. It's like the unit rate that we learned before. So the unit rate that we learned in grade 7, I think. So you don't need to worry about it. If you need more a problem like this, I will explain for you. Don't worry about that. Let's continue our work. We are going to do exactly same thing with the first part and using exactly the same number. The only thing that we need to change only this one, which is the meter cube, which is this number. Only this number, we need to change it. We need to change the volume that they gave us. So instead of 1.13 times 10 to the power 7, I'm going to use 200. So let's find it. So the molecules of water, I'm going to write only MO. I don't want to write M alone, just because I don't want you to think that is meter or, yeah, I don't want you confused with the meter, but molecules of water. But I don't want to spend long time just writing. So we have this 200, and I'm going to use exactly the same numbers that given in the previous part, which is 9.98 times 10 to the power 5 times 3 point. That's what we had from where these? From the previous example. From the previous example. 0.34 times 10 to the power 22. So I'm going to multiply all these, but first of all, I need to write this one in scientific notation. Look at this. Write your answer in scientific notation. That's why I went back and I just told you need to write this, your answer in scientific notation. So scientific notation, it is just a number first number should be a number between 1 and 10 and less than 10. And the second number, it's 10 to the power and in any power. So let's me go back, and how can I write this as I did before? So that is that will be 2 times, the dot is here, the decimal is here. I'm moving 1, 2 to the left. That means it's 10 to the power 2, right? So times this 9.98 times 10 to the power 5 times 3.34 times 10 to the power 22. Now take these numbers and multiply them all together. So once you multiply them all together, you will get 66.666, many sixes here. You just need to write just 2 digits and that's enough. Estimate it also 66.7. Let's continue here. We did not continue multiplying the 10th, which is including the powers. So they all exactly the same base. So times 10 to the power 2 plus 5, 7. 7 plus 22, it's 29. So that is times 10 to the power 29. Since they said scientific notation, I have to do this step. Move your decimal here so you can have a number less than 10. So 6.67 times 10. Add 1, you moved your decimal 1, so that means you will plus 1 to your power. So it's 30. So that's for this lesson. I'm going to continue with you, inshallah, this lesson in the next video. Bye, girls.